All right, here we go for the last review for the last test of the year. So give yourself a pat on the back. You've almost made it. The last test over Redox will have 16 multiple choice, 7 matching, and 12 short answer. So let's get going. Oxidation is loss of electrons, reduction is gain of electrons. Remember, when something's oxidized, its oxidation number gets more positive. And then when something is reduced, it gets less positive because what it's gaining is electrons and they are negative. Remember that the next one is anox, and anox stood for anode oxidation. That means at the anode, oxidation occurs. Red cat stood for reduction cathode. So at the cathode, reduction occurs. Remember that the cathode is positive, and forgot to say that the anode was negative. And the last one, fat cat, it talks about how the electrons flow, and remember that they flow from the anode to the cathode. So remember that the cathode is getting bigger. When we did our lab with the pennies, remember the penny got bigger because we plated it with the zinc. So the penny was in fact the cathode. And then the zinc metal that we had in the solution was our anode. All right, so make sure you remember those. They will help you on the test. I still to this day use it, and I've been teaching this for a long time. All right, so one of the things you definitely need to know is how to assign the oxidation numbers and using the set of rules we used in our notes. So pause the video and take a second or two to assign those if you haven't already done it. Hopefully you've already got this review completed since it was for Parker points. One note is I want to change group 13 to aluminum because that's really the only thing that we're going to be concerned about in that group, that we can always say that it is the same charge. So take a few seconds to look at that and see if you did it right. So hopefully you got all those right. So let's move on to the next slide. So this particular question asks you to find the oxidation number of sulfur and oxygen in SO3 2- and also in H2SO3. I want to add SO4 2- because, quite frankly, these two are the same thing. You've got SO3 here and SO3 here. They're going to be the same. So I want you to practice doing, actually, just do SO3 and SO4, and let's see what you get. All right, so for an SO3, your sulfur is a +4, and your oxygen's a -2. And for SO4, you would be a +6 for sulfur, and an oxygen is a -2. So oxygen stays a -2 because that's according to our rules, and a compound oxygen is a -2. So in order to balance out that charge to be an overall of a -2 on both of those, we see that sulfur has to be a +4 in that case and a +6 in that case. Okay, so next question is, in oxidation, what happens to the oxidation number? And of course we say that when we have oxidation, we increase the oxidation number. We also said becomes more positive, so that's the way we remembered it. And then for a reduction, we said that there is a decrease in the number, or we said it became less positive. So make sure you practice that a little bit so you can kind of understand that, because you will have to identify on the test what's being oxidized and what's being reduced. So this is number 4, and it asks you to assign oxidation numbers and answer the questions. Make note that we changed the this right here to CH4 from C3H8. With C3H8, your oxidation number of carbon ends up being a fraction, and that kind of throws kids for a loop, so we changed it to CH4. So we're going to pause the video and answer these questions and see how we do. So for CH4 and O2 being combusted and going to CO2 and H2O, here's what we have. We see that carbon went from a -4 oxidation number to a +4. So that means it lost 8 electrons. And then the oxygen went from a 0 to a -2 on its oxidation number, so that means it gained 2 electrons. So since carbon lost electrons, it is oxidized, and whatever is the oxidizing agent, or whatever is oxidized, Whatever is oxidized is the reducing agent because it causes the other thing to be reduced. But because carbon was in a compound, the entire compound, remember, is your reducing agent. So we would put CH4. And the reason we do that is because if we just put carbon and oxygen together, we would not actually get this reaction. We'd get something different. And then when it comes to what is reduced, we saw that oxygen went from a 0 to a -2, so it definitely gained electrons, and so it was reduced. And because it was reduced, it causes the carbon to be oxidized, so whatever is reduced is the oxidizing agent. And again, the compound is O2. In this case, it's the molecule of oxygen atoms. I kind of highlighted what goes together, so you can kind of make sure you know that. But remember, they're always opposite. So if you were to see a question on a test that said something like, what is the reducing agent? You should say to yourself, if it's the reducing agent, it means to be oxidized. And then you would go to the problem and then look and see what's oxidized so that you don't get that backwards on a test. So make sure you are aware of that on a test because that trips a lot of kids up sometimes. Is O2 plus 4 electrons yielding 2O2. Is that oxidation or reduction? And in this case, we are adding electrons, and so this would definitely be reduction. And if you look at the fact that the oxidation number went from 0 to -2, we'd know that it gained. In this one, it says, is magnesium going to magnesium 2 plus, puts 2 electrons, oxidation or reduction, and because the electrons are on the product signs, it means they went away, they got lost, and so this would be oxidation. Plus, if you look at your oxidation number, you went from a 0 to a +2, so you would know that that's oxidation. On the next problem, you can skip it. Good ways to protect a metal object for corrosion. Of course, there's electroplating, painting it, placing a metal that would be more easily oxidized in contact with it, but we're not going to need to know that for the test, so you can just skip that. What element is the most active reducing agent? If it's a reducing agent, that means it's going to be oxidized. Remember, they are opposite. And so between lithium and fluorine, the one that is most likely to be oxidized, which would make it a reducing agent, would be lithium, because lithium wants to lose its electrons. Remember, metals like to give away their electrons. They never like to take them. So if it's a free metal, it's going to be oxidized. The most active oxidizing agent, if it's oxidizing agent, it means it's going to be reduced. And we talked about this in class. Fluorine is the most electronegative element, which means it has the greatest attraction for the electrons. So it for sure is going to want to gain electrons. And so it would be reduced, making it a very strong or very active oxidizing agent. Okay? If you were to see that, remember on a test, if they ask that way, you have to think about them being opposite. If it's an oxidizing agent, it's reduced. You also need to know the oxidation number assignment rules. Those are the rules we wrote down in our notes. We wrote them down in order. And remember, you will not have them on a test, but if you think about it, you probably already know a lot of them. For instance, group 1 metals, always going to be a +1 in a compound. Group 2 metals, always going to be a +2 in a compound. Oxygen, always a -2. Don't worry about the peroxide rule. We will not see any peroxides in here. And hydrogen's a +1. Those are probably the most common ones that we'll be using, especially the hydrogen and oxygen. And then remember, when we have that one last element that we haven't assigned a number to, we no longer look at the rules. We look at our charges of the overall. If it's a molecule in a neutral compound, it's always going to be equal to 0. If it's one of the polyatomic ions like SO3 2- or NO3-, then we equal those charges to that final answer. All right, let's talk about electrolytic and voltaic or galvanic cells. First of all, this question asks how they are different. But before we talk about how they're different, let's talk about how they are the same. And those were those acronyms we talked about. ANOX, which means anode has the oxidation. Red cat, which means reduction happens at the cathode. And electron flow is anode to cathode. We said fat cat because the cathode gets bigger. That is the same for both an electrolytic and a voltaic cell. So that's some of their similarities. And they're both redox reactions that happen in both of them. So that is their similarities. Their differences. Electrolytic cell is a non-spontaneous, meaning it won't happen on its own, versus being a spontaneous in a voltaic. In an electrolytic cell, the whole reaction happens in one cell. That's what we did in the penny lab. Everything happened in one beaker. A voltaic cells has two half cells, or basically what's happening is each half reaction is going on in its own cell, or if we were to do it in the lab, it'd be going on in its own beaker. With the electrolytic, because we are supplying the battery source, it takes electrical energy and makes a chemical change out of it. Or in the case of the penny, we did a physical change, and then chemical change to electrical for a voltaic. And then an electrolytic is negative voltage, and then a voltaic cell will produce a positive voltage. So here's anox and red cat again. Oxidation happens at the anode and it's negative. The anode is negative. Red cat, reduction happens at the cathode. The cathode is positive. Electroplating, it says what is electroplating, and that is basically coating, I forgot to write that down, coating with a metal. And so it provides a protective coating and keeps the inner part of the metal from being exposed to the air. And then it said in the penny lab, which was the anode, was the penny the anode or the cathode? And of course it was the cathode. Remember fat cat, it actually got bigger because we were actually taking the zinc atoms and plating them onto the cathode. So if we had taken the mass before, we would see that obviously the mass of the penny got bigger because we added zinc atoms to it. All right, so the last part is the definitions. Hopefully you did those when you got your Parker points, but let's see if you got the right definitions. Oxidation is the loss of electrons. That means your oxidation number is going to get more positive because it's losing negative electrons. Oxidizing agent means it causes oxidation, so it causes the other thing in the reaction to be oxidized. It itself is reduced. The oxidation number is the positive or negative number that we assign to an atom according to the arbitrary set of rules that we've set forth. Reduction is gain of electrons. That means that the oxidation number is going to get less positive because it's gaining negative electrons. The reducing agent causes reduction, so it causes the other thing in the reaction to be reduced. It itself is oxidized. Remember, they are opposite. The definition for a redox reaction is the chemical changes that occur when electrons are transferred between reactants. And then lastly, a spectator ion. It wasn't really in the notes. When we were practicing, we talked about it though. The spectator ion is the thing that isn't changed in a reaction. So its oxidation number doesn't change. It doesn't participate in the transfer of electrons. So we call it a spectator ion. A lot of times hydrogen was when it stayed in a compound. And so when we look at a balanced equation and we look at the charges, if we have something that stayed the same on both sides, meaning it didn't change its oxidation number, then that is going to end up being a spectator ion. Okay? You should study your notes. You should do that quizzes one more time over the weekend if you have a chance. And that, my friends, is the last review you'll have to do for this year, of course, unless you have to take the final, but the last regular test. So let's get a whoop whoop for that. All right, let's see who won the jokes. All right, so I only had 3 kids turn in jokes to me, so all 3 will be featured. First, we're going to do our jokes by Trevor Wilson from first period, formerly from 5th period. And he says, why did the physics teacher break up with the biology teacher? There was no chemistry. His second joke was, why do the French like to eat snails so much? Because they can't stand fast food. Justin S. from 7th period says, 2 chemists go to a bar. The first one says, I think I'll have some H2O. The second one says, I think I'll have some H2O too. And then he died. How about this one? A neutron walks into a bar and asks how much for a drink. The bartender responds, for you, no charge. Thank you, Justin. So our last joke comes from Dominique, also in 7th period. and she wants to know what happened when the cow jumped over the barbed wire fence. It was utter destruction. Now those were sodium funny.